Ever pondered about the invisible forces shaping the Milky Way? In the vast expanse of our cosmic backyard, the Milky Way, a silent yet powerful architect is at work. Cosmic tides. Much like earthly tides, these are not made of water, but of gravitational forces. They exert a profound influence on the stellar landscape, shaping and reshaping the cosmic tapestry we call home. Our galaxy, the Milky Way, is a barred spiral galaxy, a bustling metropolis of stars, gas, dust, and dark matter. Within this cosmic city, every entity, from the smallest star to the most massive molecular cloud, exerts a gravitational pull on everything else. This intricate network of gravitational interactions gives birth to what we term as galactic tidal forces. But the story doesn't end within the limits of our galaxy. The Milky Way is not a solitary wanderer in the cosmos. It's part of a larger cosmic community, interacting with a host of satellite galaxies, dwarf galaxies, and globular clusters. The gravitational interplay between the Milky Way and these cosmic companions also generates tidal forces. Imagine a cosmic tug-of-war. On one side, we have our home galaxy, the Milky Way, with its immense gravitational might. On the other side, we have a smaller satellite galaxy or a globular cluster. This cosmic tug-of-war can deform and even disrupt the smaller companions, a process known as tidal stripping. This process sculpts the stellar streams and halos that surround the Milky Way, adding another layer of complexity to our galaxy's structure. So, the cosmic tides within the Milky Way are not merely a result of interactions within the galaxy. They are also a testament to the galaxy's interactions with the universe beyond its stellar boundaries. They tell a tale of cosmic interplay, a tale of gravitational ebb and flow that shapes the very structure of our galaxy. Cosmic tides, a silent yet powerful architect orchestrating the symphony of celestial bodies within our Milky Way. Our Milky Way doesn't exist in isolation. It's part of a grand cosmic community, a bustling neighborhood filled with satellite galaxies, dwarf galaxies, and globular clusters. This celestial interaction is much like a galactic tango, where each partner influences the other's steps and movements. Gravitational forces become the rhythm of this cosmic dance, shaping the partner galaxies as they interact and collide. Now, let's introduce a key player in this dance, a process known as tidal stripping. Imagine a smaller dance partner, a dwarf galaxy spinning too close to its larger companion, the Milky Way. The overwhelming gravitational pull of the Milky Way can strip away the outer stars and gas of the dwarf galaxy, leaving behind a core of stars. This process, this dance, leaves a lasting impact on both galaxies, reshaping their structures and influencing their futures. Like a cosmic ballet, the Milky Way and its companions dance, shaping each other through their gravitational pas de deux. Consider the Sagittarius dwarf galaxy, a close companion and a victim of our galaxy's tidal forces. This pint-sized galaxy is a fascinating study in the cosmic ballet orchestrated by the gravitational interplay within the universe. The Sagittarius dwarf galaxy, or SAGI as astronomers affectionately refer to it, is one of the many satellites of the Milky Way. This means it orbits our galaxy, much like the Earth orbits the Sun, but its journey is not a peaceful one. As it orbits, it's constantly grappling with the tidal forces of the Milky Way, a struggle that shapes its destiny in a dramatic way. Picture a small boat in the ocean, being tossed about by the waves. The Sagittarius dwarf galaxy is that boat, and the waves are the gravitational forces of the Milky Way. But unlike a boat that can ride the waves, SAGI is pulled and stretched by these forces. As it orbits the Milky Way, its stars and gas are tugged, causing them to stretch out and deform the dwarf galaxy. But what does this cosmic tug-of-war result in? A stunning spectacle of tidal streams and debris. Tidal streams are essentially rivers of stars, gas, and dark matter, torn from the dwarf galaxy by the tidal forces of the Milky Way. These streams trace the orbit of the dwarf galaxy, stretching out in long arcs across the sky. They are the silent witnesses of the cosmic drama unfolding between the Milky Way and its satellite galaxies. The debris, on the other hand, is the fallout from this interaction. It's the scattered remnants of stars and gas, ripped from the Sagittarius dwarf galaxy and left behind in its orbit around the Milky Way. These stellar breadcrumbs provide astronomers with valuable clues about the history and nature of this interaction. A galactic interloper, Sagittarius leaves a trail of stellar breadcrumbs as it pirouettes around the Milky Way. So the next time you gaze up at the night sky, spare a thought for our tiny companion, dancing its eternal dance with our Milky Way in the grand ballet of the cosmos. Stellar streams, the cosmic rivers, bear witness to the Milky Way's tidal history. These elongated structures of stars are the remnants of satellite galaxies and globular clusters, disrupted by the immense gravitational forces of our galaxy. Imagine a cosmic dance where smaller celestial partners are stretched and deformed into streams of stars as they succumb to the gravitational embrace of the Milky Way. These streams, like rivers in the cosmos, weave their path through our galaxy, leaving behind a stellar trail. They are the silent storytellers of past tidal interactions, marking the paths of celestial companions long consumed by our galaxy. They serve as the celestial breadcrumbs, allowing astronomers to trace back the intricate history of galactic encounters. The stellar streams remind us of the dynamic nature of our galaxy, ever-changing under the influence of tidal forces. These stellar rivers, charting the cosmos, narrate tales of galactic encounters and cosmic cannibalism. Meet the invisible sculptors of our galaxy, halo stars and dark matter. These unseen forces play a significant role in molding the structure and dynamics of the Milky Way through tidal interactions. The dark matter halo is an enigmatic component of our galaxy, a colossal unseen mass that envelops the Milky Way. It's not made of stars, gas, or any other familiar matter. Instead, it consists of a mysterious substance known as dark matter, detectable only through its gravitational effects. This invisible entity responds to tidal forces, redistributing its structure and influencing the overall shape of our galaxy. Intriguingly, the halo is not a static entity. It evolves over time, responding to the ebb and flow of galactic tides. As the Milky Way interacts with its cosmic neighborhood, tidal forces reshape the distribution of stars, gas, and dark matter within the halo. Halo stars, the stars that reside in the dark matter halo, offer a unique perspective on this process. They are the silent witnesses to the galaxy's intricate gravitational ballet. By studying these stars, astronomers gain a unique lens through which they can probe the galactic tides and infer the underlying dynamics of dark matter. These invisible sculptors, the dark matter and halo stars, play a critical role in shaping the Milky Way. They are the unseen hands that mold the galaxy's structure, influencing its spiral arms and central bulge. Through their silent and relentless work, they shape the visible tapestry of our galactic home. In the cosmic theater of the Milky Way, dark matter and halo stars are the unsung heroes, the stagehands behind the scenes. Their roles may be invisible, but their impact is profound, shaping the galaxy as we know it. And though we cannot see them, their influence is written in the stars. In the silent darkness, these unseen entities shape the visible tapestry of our galactic home. Tidal forces, a key player in the grand saga of galactic evolution. These ubiquitous forces not only shape the overall structure of the Milky Way, but also choreograph the orbital dance of stars within it. Just like a ballet dancer responding to the pull of gravity, stars too can experience radial migration under the sway of tidal perturbations. This celestial choreography reshapes their positions and velocities within the galaxy, adding another layer of complexity to the intricate tapestry of galactic evolution. Moreover, tidal forces play a crucial role in the birth of new stars. By compressing and rarefying molecular clouds, they set the stage for the creation of stellar nurseries. As new stars are born and evolve, their interactions with the galactic environment further mold the Milky Way's structure and dynamics. In this cosmic theater, tidal forces are the invisible puppeteers, pulling the strings of galactic evolution. How do we perceive these invisible tides in the cosmos? Well, it's a bit like trying to hear a whisper in a hurricane. Yet despite the challenges, astronomers have developed innovative ways to observe and study these cosmic tides. They utilize precise astrometry and spectroscopy, along with large-scale surveys, to map the distribution of stars, gas, and dark matter across the galaxy. These techniques allow them to detect subtle changes in the movement and composition of stellar bodies, hinting at the underlying tidal forces at play. Additionally, astronomers employ complex algorithms and simulations to interpret these observations and predict the unseen dark matter dynamics. But it's not just about the data. It's also about interpreting the cosmic story these tides tell, a story of celestial dances, galactic interactions, and the ever-evolving face of our Milky Way. Armed with our telescopes and algorithms, we continue to navigate the cosmic tides, furthering our understanding of the universe we call home.